Welcome to our channel, where we explore the incredible forces of nature, the mysteries of space, and everything in between. Today, we delve into one of the most awe-inspiring and potentially catastrophic natural events on Earth, the Yellowstone Supervolcano. It's not just a geological marvel, it's a ticking time bomb, capable of reshaping the entire planet in ways that are difficult to imagine. Beneath the serene beauty of Yellowstone National Park, with its bubbling hot springs, towering geysers, and vibrant wildlife, lies an immense and terrifying force. Hidden beneath this breathtaking landscape is a supervolcano, a colossal volcanic system that has erupted multiple times in the past, with each eruption altering the Earth's climate, geography, and ecosystems. While most visitors to Yellowstone marvel at its picturesque scenery, few realize that they are standing atop one of the largest active volcanoes on the planet. The entire park sits on a vast volcanic caldera, the remnants of a super eruption that occurred over 640,000 years ago. This was not just any eruption. It was a geological event of such magnitude that it left a massive depression in the Earth's crust, covering an area of approximately 1,500 square miles. This eruption unleashed more than 1,000 cubic kilometers of volcanic material into the atmosphere, blanketing much of North America in ash and profoundly affecting the global climate. The term supervolcano may sound like something out of science fiction, but it is a very real threat. Supervolcanoes are capable of ejecting more than 1,000 cubic kilometers of material in a single eruption, a volume so large that it can cause global climate changes, block sunlight, and disrupt ecosystems worldwide. In contrast, a typical volcanic eruption, like Mount St. Helens in 1980, releases just 1 cubic kilometer of material. This stark difference underscores the unimaginable scale of a supervolcano eruption. Over the last 2.1 million years, the Yellowstone Supervolcano has erupted 3 times. Each eruption was cataclysmic, reshaping the landscape, altering the planet's climate, and causing widespread destruction. The first eruption occurred 2.1 million years ago, creating what is now known as the Huckleberry Ridge Tuff. This event was the largest of Yellowstone's eruptions, ejecting approximately 2,500 cubic kilometers of material. The second eruption, which occurred 1.3 million years ago, was slightly smaller but still massive, forming the Island Park caldera. The most recent eruption, 640,000 years ago, created the Yellowstone caldera and ejected over 1,000 cubic kilometers of volcanic material. In recent years, scientists have observed a series of alarming developments beneath Yellowstone. A 100-foot-wide crack has appeared in the Earth's crust, suggesting that the supervolcano is far from dormant. This crack, located in the Norris Geyser Basin, is a manifestation of the immense pressure building beneath the surface. The Earth's crust in this region is being slowly pulled apart as the magma chamber below becomes more active. Geologists believe this crack is a clear warning sign that the supervolcano is restless, and that the likelihood of an eruption may be higher than previously thought. In fact, recent studies have shown that the risk of a Yellowstone eruption has increased by a staggering 320%. This is a significant shift and has raised concerns among scientists who are closely monitoring the area for signs of increased volcanic activity. The crack in the Earth's crust is just one of many indicators that Yellowstone's supervolcano is becoming more active. Seismic activity in the region has also increased in recent years, with a series of small earthquakes rattling the park. While earthquakes in Yellowstone are not uncommon, the recent uptick in seismic events suggests that the magma chamber below may be shifting, causing the ground to tremble as molten rock moves closer to the surface. But what does all this mean for the future? Could Yellowstone erupt in our lifetime? And if it does, what would the consequences be? The Yellowstone supervolcano is not your typical volcano. Most volcanic eruptions involve the release of molten rock, or lava, from a magma chamber beneath the Earth's surface. These eruptions can be devastating, but they are usually confined to a relatively small area. Supervolcanoes, on the other hand, are capable of producing eruptions of such magnitude that they can affect the entire planet. When a supervolcano erupts, it doesn't just spew lava. It ejects massive amounts of ash, gas, and volcanic debris into the atmosphere, which can block sunlight and cause global temperatures to drop. This phenomenon, known as a volcanic winter, can last for years, leading to widespread crop failures, food shortages, and even mass extinctions. The ash from a Yellowstone eruption would be particularly devastating. Volcanic ash is made up of tiny, sharp particles of rock and glass that can travel hundreds of miles from the eruption site. When these particles settle, they can blanket entire regions in a thick layer of ash, collapsing buildings, suffocating plants, and contaminating water supplies. The ash cloud could also disrupt air travel, grounding flights across the globe as ash particles clog jet engines. In addition to the immediate destruction caused by the ash, the sulfur dioxide released during the eruption would mix with water vapor in the atmosphere, creating acid rain that could further devastate ecosystems. But the most concerning consequence of a supervolcano eruption would be the impact on the climate. The sulfur dioxide released during the eruption would form a reflective layer in the atmosphere, blocking sunlight and causing temperatures to drop. This drop in temperature could trigger a volcanic winter, a period of prolonged cooling that could last for years. During a volcanic winter, growing seasons would be shortened, crops would fail, and food supplies would dwindle. The resulting food shortages could lead to widespread famine, social unrest, and even conflict as nations struggle to feed their populations. While it's impossible to predict exactly when Yellowstone will erupt, scientists are working tirelessly to monitor the supervolcano and better understand the processes that could trigger an eruption. In recent years, advances in technology have allowed researchers to create detailed images of the magma chambers beneath Yellowstone using seismic wave data. These images have revealed that the magma system beneath the park is far more complex than previously thought. Beneath Yellowstone, there are two massive magma chambers stacked on top of each other. The upper magma chamber, located 3 to 6 miles beneath the surface, contains a mixture of solid rock and molten material. The lower chamber, located 12 to 30 miles below the surface, is much larger and contains a higher concentration of molten material. These two chambers are connected by a network of conduits that allow magma to flow between them. Understanding how magma moves through this system is crucial for predicting when and if a future eruption might occur. One of the biggest challenges in studying Yellowstone's supervolcano is the sheer scale of the system. The magma chambers are so vast that even small changes in their behavior can be difficult to detect. However, scientists are using a combination of seismic data, GPS measurements, and satellite imagery to track changes in the ground level and monitor the movement of magma beneath the surface. The ground in Yellowstone has been rising and falling in dramatic fashion over the past few decades, a phenomenon known as ground deformation. This is caused by the inflation and deflation of the magma chamber beneath the park. When magma enters the chamber, the ground above it rises, and when the magma leaves the chamber, the ground sinks. Between 1996 and 2014, the ground in the Norris Geyser Basin rose and fell by more than 5 inches, a clear indication that magma was moving beneath the surface. In 2014, Yellowstone experienced one of its strongest earthquakes in recent history, a 4.9 magnitude quake that shook the entire park. This earthquake was caused by the movement of magma beneath the surface and was a stark reminder that Yellowstone's supervolcano is still active. The earthquake was followed by a period of increased seismic activity, with hundreds of smaller quakes rattling the region over the following months. One of the most fascinating indicators of Yellowstone's volcanic activity is the Steamboat Geyser. This geyser, located in the Norris Geyser Basin, is the tallest active geyser in the world, capable of shooting water and steam more than 300 feet into the air. For decades, Steamboat was an unpredictable geyser, sometimes going years without erupting. But since March 2018, Steamboat has erupted with increasing frequency, sometimes as often as once a week. This sudden increase in activity has puzzled scientists and raised concerns that it may be linked to a buildup of pressure in the magma chamber below. Could Steamboat's increased activity be a sign that the supervolcano is becoming more active? Some researchers believe it could be. Geysers like Steamboat are powered by the same geothermal forces that drive volcanic eruptions, and changes in a geyser's behavior can sometimes indicate changes in the underlying magma system. The fact that Steamboat is erupting more frequently could be a sign that pressure is building in the magma chamber, pushing steam and hot water to the surface more often. But Steamboat is not the only geyser showing signs of increased activity. The entire Norris Geyser Basin has become more thermally active in recent years, with temperatures rising and new hot springs forming in the area. Some of these new thermal features have appeared in areas that were previously considered stable, suggesting that the geothermal system beneath the park is becoming more dynamic. While the likelihood of a supervolcano eruption in the near future remains low, the consequences of such an event would be catastrophic. A massive eruption would not only devastate the immediate area, but it would also have far-reaching effects on the global climate, agriculture, and economies. The resulting ash cloud could block out sunlight for years, leading to crop failures, food shortages, and widespread social unrest.